The diagram shows monochromatic light of frequency f incidence on a metal surface. The frequency of the light is higher than the threshold frequency. When an electron absorbs a quantum of light energy, hf, some of the energy of the photon is used to free the electron. The remainder shows up as kinetic energy K of the electron emitted. If the energy required to free the electron is E, then by conservation of energy, hf equals E plus K. The least tightly bound electron will have the maximum kinetic energy, K maximum. Most of the electrons emitted have less kinetic energy than K maximum because they undergo collisions before they escape from the surface of the metal. Click the Emission of Electron button to view the emission of the electron from the metal. Click the Mechanical Analogy button to see the mechanical analogy of the photoelectric effect. The work function of sodium is 2.75 electron volts. If light of wavelength 434 nanometers is incident on a sodium surface, A. What will be the maximum kinetic energy of the emitted electrons? Click the Solution button to check your answers. Click the Next button. B. What will be the maximum speed of the electrons? Click the Solution button to check your answers. Summary. hf equals W plus K maximum is known as the Einstein's photoelectric equation. The diagram shows a photocell circuit in which the potential difference V across the anode and the cathode can be varied. When the potential difference is zero, a photoelectric current is observed. To study the relationship between the photoelectric current I and the potential difference V of the photocell, drag the slider of the potential divider to vary the potential difference. What do you observe? Answer. Initially, the photoelectric current increases as the potential difference is increased. The photoelectric current then reaches a maximum value and remains constant even though the potential difference is increased further. Click the Part 1 button and the Part 2 button to interpret the shape of the graph. Does the intensity of light affect the maximum value of the photoelectric current? Click the Intensity button and observe the maximum photoelectric current on the graph. The maximum value of the photoelectric current increases with the intensity of the incident light. When the anode is positive with respect to the cathode, the variation of the photoelectric current with the potential difference across the anode and the cathode is as shown in the graph. The batteries in the photocell circuit are reversed so that the anode is negative with respect to the cathode. Move the slider of the rheostat towards B so that the anode is more negative with respect to the cathode. What do you observe about the microammeter reading? Answer: the microammeter reading decreases. When the slider is at a particular position, the microammeter reading becomes 0. The potential difference across the cathode and the anode when there is no photoelectric current is known as the stopping potential Vs. The stopping potential is the potential difference that stops the most energetic photoelectrons from reaching the anode. An electron which is emitted from the cathode and moves towards the anode will stop when all of its kinetic energy has changed into electric potential energy. Click the Part 3 button to interpret the graph when the potential of anode is negative with respect to the cathode. If the intensity of the light increases, does the stopping potential change? Click the Intensity button to obtain the answer from the graph. The stopping potential is independent of the intensity of the incident light. It follows that the maximum kinetic energy of the photoelectrons is independent of the intensity of the light. Is the maximum photoelectric current dependent on the intensity of incident light? Answer: yes. The magnitude of the maximum photoelectric current increases when the intensity of the light increases. Click the Cathode Material button and observe the graphs of photoelectric current versus potential difference V for two different cathode materials. Does the stopping potential depend on the cathode material? Answer: yes. Different cathode materials have different stopping potentials. Cesium has a smaller work function. Hence, photoelectrons have higher maximum kinetic energy and therefore a higher stopping potential is required. The graph shows how the photoelectric current I varies with the potential difference V across the anode and the cathode when light of the same intensity but different frequencies F1 and F2 are incident on the photocell. What can you deduce from the intercepts on the potential difference axis? Answer: the intercepts are the potential differences for which no photoelectric current flows. Hence, these are the stopping potentials for frequencies F1 and F2. The stopping potential is higher for light of higher frequency. Thus, the maximum kinetic energy of the photoelectrons increases when the frequency of the incident light increases. The graph shows the variation of the stopping potential Vs with the frequency f of the incident light. What can you deduce from the intercept on the frequency axis? Click the answer button. What can you deduce from the gradient of the graphs? Click the next button to check your answer. What can you deduce from the intercept on the stopping potential axis? Click the next button to check your answer. The work function of cesium is 2.14 electron volt. A. What is the maximum wavelength of the incident light that will eject electrons from a cesium surface? Click the solution button to check the answer. Click the next button. B. What is the maximum kinetic energy of electrons ejected from a cesium surface by light of wavelength 500 nanometers? Click the solution button to check the answer. Click the next button. C. Determine the stopping potential for the photoelectrons. Click the solution button to check the answer. Summary. The stopping potential or the maximum kinetic energy of the photoelectrons increases linearly with the frequency of the incident light. The maximum kinetic energy of the photoelectrons is independent of the light intensity. K maximum equals EVS.